3 years ago, we've introduced the first ever wireless fuel level sensor, featuring the battery that lasts 7 years, featuring the military-grade materials, featuring very logical electronic board, and that's it. First case I would like to tell you about, it's stationary tank monitors, or the asphalt plant back in Siberia. The year of the implementation was 2019. The first one, integrator faced this task from the end user. The solution was kind of obvious, to use capacity fuel level tanks. But then later on it came on to light that the tanks were lifted 7 meters above the ground, and the boards where these sensors had to be connected were more than 10 meters away. So if they would have used the wire fuel level sensor, they would have to run the wires all the way to the control board and also take some measures to protect the wire from human factors, from possible malfunctions, from possible weather conditions and such. So after the fuel level sensors were installed, the end user was able to get all kind of fuel data out of the tanks. Any suspicious activity, the fuel consumption, why do you need the fuel on the asphalt plant? It is used to manufacture asphalt, and it's also used to power up the engines and power up all kind of equipment that is connected to this production. The next case I would like to tell you, this was implemented by a viable operator from Belarus, Belarus Neft. This is an affiliated company with the Belarus Neft, which is a state-run oil company in Belarus. The company does engage in the transportation of petroleum and its derivatives located in rural Belarus. So the main challenge was to monitor the fuel level inside of the moving tanks, and also to monitor the opening and closing of the hatch. The hatch is located on the bottom of the fuel transporter. Basically looks like this, and it's used to access all types of the valves and all types of the fuel dispensers. So what they did, they installed the DU wireless angle sensor for this particular hatch. So when open and closed, you can see the location, you can see the time of the opening and closing of these hatches. So even during the test period, the sensor was very quick to show the attempted theft on one of the trucks. One of the next case is field monitoring for the agricultural holding. Comas Group, it's one of the major agricultural holdings engaged in production of milk, transportation of these products to the end users, meaning the supermarkets and places like this. So they've, their fuel spendings, if I'm not mistaken, were approximately $190 million per year for the whole fleet. And they had to live with the thought that some of this money is being stolen, some of the fuel is being drained or siphoned, or maybe there are some documental discrepancies. So they equipped with Escort DBLE, they equipped 150 trucks across the country, and the integrator for this project was Gurtam Innovations. Basically, they were able, equipment costs and installation amounted for $40,000. And the funds saved in 6 months after equipment installation was $115,000. So that amounts for $75,000 saved in 6 months after the cost. Good money, I think so. And especially with this peace of mind, they are able to monitor the exact fuel consumption and get this big picture of how the trucks behave, are they over-consuming fuel, do they need some kind of the maintenance, who is the worst driver, who is the best driver, who is the driver they have to fire, to let go. This is the line of the products that we manufacture. Those are telematics sensors and IoT solutions, including fully autonomous weather station and industrial gas analyzer. So all these projects were possible with our sensors and with our equipment. Thank you very much for your attention. Yeah, I'll be frank, before the coffee break, perhaps you guys are already tired and really want to drink some coffee. Yeah, if you have any questions, I'm ready to answer.
Yes, actually it's very interesting technology and sensor. I have a question about the integration part. This level of integration with other devices can be done over like protocol or API?
Absolutely. The protocol is basically Bluetooth protocol with some added encryption, so there is no access by an authorized person. The way we do integration is we did with NAV Telecom, with Galileo Sky, with some other tracker manufacturers not present here. We exchange protocols. Basically, we file the protocol, they do implementation of this protocol with our help. Then they ship us the device with integrated protocol, which we test in our lab, in our factory, and then we issue some kind of a marketing announcement that we have integrated. So far, it proves boost of sales for both companies.
I agree. The second question is, because you are using the Bluetooth technology, right, as a carrier, from your experience, what is the maximum distance you can reach? Because I saw some project is quite interesting, like long distance. So using the Bluetooth, how can you utilize the distance?
The sensor broadcasts at constant power. Basically, it's always in broadcast mode. Now we have to have receiver sensitive enough. There are quite a few options. We supply optional adapter that converts the BLE signal into RS-485 LLS. Those are for the GPS trackers that may not have Bluetooth, for example, or it also acts as an external antenna. In real line of sight, when the vehicle was standing up on the road, I was walking away, and I walked away as far as 200 meters. Never happens in real life. Okay, so we have in real life, when we have no receiver, so we talk about direct connection over the Bluetooth between the tracker. Now we depend a lot on how good quality, how the quality of the tracker is. 10 meters, considering the walls of the cab, considering the truck body inside. Then again, we after 3 years of experience, we found out that it's not universal. So you cannot use the BLE for every occasion. There was a situation when the GPS tracker was installed in the front of the bus and the fuel level sensor was installed in the back of the bus. When the bus was empty, no problem. But then when the bus got full, that's it. No signal goes through the body. It's one of the main challenges. We are working on Bluetooth 5.0. The next one is going to be so that shoots further. So for the regular application like trucks, like big mixers, the long hauling trucks, or any kind of transportation vehicle, it works just fine.
Thank you very much.
Absolutely.
Thanks, Tim, for the presentation. Regarding the battery, have you had any study on the degradation of the battery over years? And when you plan to replace the battery, this is a special battery now, so how do you get this sorted out?
Yeah, you're right. When the device was new, when we just made it about 3 years ago, there was a lot of different trials with different batteries. And then essentially we changed quite a lot over the years, such as the battery holder, such as the formula of the compound, because we found out when being on heat for the prolonged period of time, the old compound used to bubble, and then it pushed the battery out of this holder, so we had to take the sensor back. The battery is French, The size of it is AA, and it's possible to purchase direct from the manufacturer or from us or from the local store. The only thing it has a certain type of voltage, 3.5. It's possible to replace it if needed. The compound is two-layered, so we have the first layer of the polyurethane where the electronic board is sealed, and the second layer is the silicone. So basically, by using regular tools like a knife and a screwdriver, you can pull the battery out, you can put the new one again, and then you can use this silicone automotive sealant. Mathematical calculation based on the power consumption of the sensor and the battery, ampere hours, showed us 12 years of the battery life. So just to be on the safe side, mathematical calculation all it is, people like it's a completely different story. We claim 7 years of battery life. So that's the time, but the warranty on the battery from the manufacturer is 3 years. So this battery being an integrated part of the sensor, we can give 3 years warranty on the sensor. So if it dies within 3 years, we are replacing the sensor, the battery, whatever. So, but the first ones we have up in Siberia, and one of the sensors, they always are outside for temperature testing. So if you come to the older sensors, you connect to them, they show 3.2, 3.1, which is normal for that age. Meaning voltage, 3.2 volts.
Okay, normally we use the wired sensors for the heavy vehicles. So mostly we get difficult or challenges when we are doing the calibrations. So is it the same system when doing the calibration with the same wire and the wired one, or is it different in more easier way?
It's the same if you compare it to our wired sensor. So the basic, the measuring part and everything is just the same, except it's powered by the battery. But the calibration, yes, it has to be done. However, until this summer, we didn't have it. We had to collect a lot of deep data and do a lot of analysis to eliminate the first stage of the calibration. So when we got the sensor measuring part, now the sensor head doesn't know how long it is. So we have to make a full and empty calibration. We introduced dry calibration. So it's possible to use fuel to calibrate the sensor after cutting, but it's also possible to do the dry calibration. So how it looks in real life. You cut the sensor to the size of the tank, because it has to be as long as deep the tank is. Then we hit dry calibration. Now it's calibrated and it's ready to be installed. So the next step is the tank calibration. Basically, we have to teach the sensor, what tank it was installed by creating a calibration table, which is the same. You have to do the portions of, the fillings and such. There are ways. Some people prefer to do it manually. Some people use calibration machines, which are also there on the market. Some of my clients, especially in South Africa, when they have a tank with a rectangular shape and there's a linear dependency regarding the movement of the fuel inside of the tank, they just do 2-point calibration. They do empty and full, and they let it go. So they're happy with the accuracy. Most of the Russian and European customers, they do manual calibration by filling the portions of the fuel every 5 liters or so. So yeah, to answer your question, that the process is the same to achieve the accuracy.
Thank you.
For big tanks though, it's possible if you provide accurate measurements of the inside of the tank, we can make a mathematical calibration table for you. If you have the 40,000 liter tank, So based on that measurements, we can create a mathematical calibration table. Should be good enough based on this, measurements.
Sorry, just want to add on to that one. So how does the calibration work in the extreme weather conditions? Because of the fuel expense, right?
Mm-hmm. The sensors are equipped with the temperature sensor. Each sensor is equipped with a temperature sensor inside of the head. And the algorithm that is, the device itself is just a device, many people make it. But the main value is the algorithms. So we have a thermal compensation algorithm, which we always have to adjust, depending on country we ship the sensors and how the behavior of, the elevation matters. The temperature drop matters. So the idea is that the temperature sensor, inside of the sensor head, measures the temperature and therefore corrects the data that it shows out to the GPS track, basically.
I have a question. The accuracy, if you compare the measuring every 5 liters and the accuracy of the dry one, which one is best? Is it the same or
The accuracy of the second you said, if you do
the dry or the conventional?
I understand. Yeah. Basically, the dry calibration, the first stage, because to do the calibration, we have to separate it in 2 stages. First, the sensor calibration. The second is the tank calibration. So when you do the dry calibration, instead of the calibration with fuel, the increments of the sensor may be different. Meaning, it's like imagine the measure. Like what's it called?
Tape measure.
Tape measure. Okay. Yeah. So for example, you have it 10 meters, right? In fact, every centimeters. But this now is going to be the same 10 meters, but it's going to be showing different values. So raw values that are shown by the sensor might be different if you don't use fuel. However, the next step when you do the tank calibration basically counteracts the first action. So the tank calibration is the most important part.
If it's many trucks, I guess you can do one.
That is a bit different, yeah. Basically, you transfer the calibration table. That is a very great experience. No, seriously, for this past year, I really wanted to talk to you about, what's your experience. Last year, you started using the fuel level sensors, and then, one of the pioneers enjoyed it really.